On November 1, 2023, an expert panel commissioned by NOAA, NASA, and ICES have acknowledged the fallacy of their prediction about the solar cycle 25 would peak in 2025. They stated that the solar activity increases more quickly and peak at a higher level than initially forecasted. There is the potential for sudden and fatal consequences for our civilization, and we'll talk about this important topic in today's episode. Watch this video to the end, and you'll uncover the most mystical mysteries of the sun, eerie secrets of our star, learn about the dire consequences of the next solar superstorm, and what UFOs have to do with it. So let's get started.
News, copyright.
Would be broken up in the open field.
The sun. It gives life, though it can sow death. Despite thousands of years of continuous observation of it, we still know too little about our luminary. In this episode, we will explore the most amazing and sinister mysteries of the sun. We'll discover how it produces energy, what causes its cycles of activity, and what are the mysterious objects that sometimes appear near it. Let's learn the history of solar flares, powerful bursts of radiation and plasma that can affect the Earth's atmosphere, satellites, and power grids. We will see how solar flares have caused major disruptions and disasters in the past, and how scientists are trying to predict them in the near future. Join us as we uncover the mysteries of the sun and how they affect our planet and our civilization. Well, let's solve the mysteries together. So, let's go over some facts you probably didn't know. The amazing sun. Did you know that at first glance the sun appears to be a quiet and calm star? In reality, it's a massive nuclear furnace racing through space at a speed of 735,000 kilometers per hour. The sun accounts for 99.8% of the mass of the solar system, with most of the remaining mass coming from Jupiter. The sun is enormous, with a diameter 109 times that of Earth. It could fit about 1.3 million Earths inside it. The sun and planets formed around 4.59 billion years ago from the solar nebula. The sun is currently in the main sequence stage, slowly using up its hydrogen fuel. It is primarily composed of hydrogen, 74%, and helium, 24%, with trace amounts of other elements like iron, nickel, and oxygen. The sun is a giant ball of plasma. Unlike a solid ball of fire, the sun is composed of super-hot, electrically charged gas called plasma. This allows for the intense fusion reactions that power the sun. The sun is losing mass, but don't worry, not fast enough to affect us. Every second, the sun converts about 600 million tons of mass into energy through nuclear fusion. However, this mass loss is happening at an incredibly slow rate and won't have any noticeable impact on Earth for billions of years. Despite being relatively close, the sun is a bright star compared to others in our galaxy. Did you know that we can't see the sun's true color? It appears yellow from Earth because the atmosphere scatters the shorter blue wavelengths of sunlight more than the longer red wavelengths. In reality, the sun is closer to white. In about 5 billion years, the sun will enter its red giant phase, expanding to consume inner planets before shrinking into a white dwarf. Did you know that the largest star known to humanity, Stephenson 2.18, has a radius equal to 2150 times that of the sun and emits light at 437,000 times the brightness of the sun? The distance from Stephenson 2.18 to Earth reaches almost 19,000 light-years. Structure and features. Different parts of the sun rotate at varying speeds. Regions at the equator take 25 days to complete one rotation, while features at the poles can take up to 36 days. The sun emits a continuous stream of charged particles known as the solar wind. This wind travels at up to incredible 900 kilometers per second. The sun has layers including the photosphere, visible surface, convective zone, heat transfer, and radiative zone, energy transport. The sun's outer atmosphere, including the corona, can reach temperatures up to 1 million degrees Celsius, much hotter than its surface temperature of 6,000 degrees Celsius. The temperature at the core of the sun is about 15 million degrees Celsius. It's common knowledge that temperature typically decreases as you move away from a heated surface. If we attempt to verify whether this holds true for the Sun and start ascending from its surface, initially we'll find that the temperature indeed drops. However then, after ascending to a very insignificant height, the temperature unexpectedly starts to rise very rapidly and reaches extremely high values. There are several hypotheses about the mechanism behind this heating, but none of them is yet compelling enough to answer all the questions that arise. Scientists are left with no choice but to include this paradox among the mysteries of the Sun. The mystery of solar cycles. Gigantic explosions called solar flares sometimes occur on the Sun, releasing as much energy as 1 billion hydrogen bombs. The Sun rings like a bell. After solar flares, it can vibrate for several days. The Sun produces all different types of light, from radio waves to X-rays. The amount varies based on its activity. Roughly every 11 years, the number of sunspots visible on the surface of the Sun increases from 0, or a very low value, to 100 or more, and then decreases again to 0 at the beginning of the next solar cycle. The nature and causes of this process represent perhaps the greatest puzzle in modern solar physics. The Voyager. The Voyager project has played a significant role in the study of the Sun and the solar system. The Voyager probes, launched in 1977, still operate using technology developed in the 1970s. Voyager 1 is expected to continue collecting data until about 2025. Voyager 1 holds the record as the most distant human-made object from Earth. It is currently about 140 AU away from Earth and remains in regular contact with the Deep Space Network. Voyager 1 captured the first ever image of the solar system from outside it on February 14, 1990, before its imaging equipment was deactivated. To communicate with potential extraterrestrial life, both Voyagers carry a golden record containing sounds and images representing Earth's diversity. This record includes greetings in multiple languages and cultural representations. And maybe these messages have been heard. At any rate, on December 12, 2023, a notice appeared on NASA's blog regarding Voyager 1 delivering an absurd series of zeros and ones to Earth. NASA thinks that one of the 3 onboard computers is malfunctioning, which would explain the problem. The potential that the probe's strange behavior may have resulted from it falling into the hands or claws, appendages, tentacles of aliens who unsuccessfully tried reprogram the onboard computer to broadcast signals, signaling their wish to make contact with humanity. Maybe the aliens are unable to communicate with us because their technology is based on completely different physical principles. Though it is just a speculation, even skeptics should agree that the likelihood of such scenario isn't 0. By the way, did you know that there are spacecraft like the Solar and Heliospheric Observatory, SOHO, continuously observing the Sun since its launch in December 1995? UFO cases. In 2012, there was speculation about a UFO spaceship orbiting the Sun based on footage from NASA's HelioViewer. Conspiracy theorists claimed that a mysterious spherical object was sucking energy from the Sun, with comparisons made to similar sightings earlier. In 2020, YouTube channels shown a footage of a large, oddly shaped UFO near the Sun. The object was described as spinning out of control and falling towards the star, leading to speculation about its nature and origin. Some believed it could be a genuine UFO sighting, while others attributed it to pareidolia, a psychological phenomenon where recognizable shapes are seen in unrelated objects. In 2022, viewers watching NASA footage of the Sun reported seeing a mysterious black cube emerging from the star before the website abruptly shut down. While some conspiracy theorists believed it was evidence of alien activity, experts explained that it was likely a glitch in the telemetry data rather than a real object. We can only marvel at the consistency with which official sources write off all the unexplained things as technical problems. Radiations and emissions. The Sun has its own weather system. Similar to Earth, the Sun experiences its own weather patterns, including solar flares, prominences, and coronal mass ejections. These can have significant impacts on Earth's technology and environment. Let's get acquainted with these types of activity of our Sun and understand the difference. Solar flares are sudden bursts of energy caused by the release of magnetic energy in the solar corona. They can last from several minutes to several hours and are often accompanied by coronal mass ejections, CMEs. Prominences are giant clouds of gas supported by magnetic fields that can float up from the solar corona. They usually have a loop or arch shape and can exist for several days or weeks. Coronal mass ejections, CMEs, are massive eruptions of plasma and magnetic field from the solar corona into space. CMEs usually occur together with solar flares, but they can also occur independently. One such mass ejection can contain, just imagine, billions of tons of material. The Miyake events. The Miyake events refer to a series of sudden increases in carbon-14 activity detected in tree rings, particularly in Japanese cedar trees. In 775 AD, researchers observed a sharp spike in carbon-14 levels, which was so significant that scientists initially thought it couldn't be explained by a large solar flare. However, later studies suggested that a massive solar flare was indeed responsible for this spike, making it the most intense solar event in thousands of years. Subsequent research confirmed similar spikes in carbon-14 concentrations in ice cores from Antarctica and Greenland. In 2013, another paper by Fusa Miyake reported a similar increase in carbon-14 levels in 993 AD. Interestingly, observations of auroras at low latitudes, such as in Germany, Ireland, and Korea, were recorded in both 774 and 993 AD. Further investigations by research groups from the USA and China identified several similar events in the more distant past. All these events were grouped together under the name Miyake events. By 2023, at least 8 Miyake events were identified. These findings demonstrate that Earth has been subjected to intense solar activity at least 8 times within a relatively short span of observable history. This suggests that similar events may occur in the future. This brings to mind the so-called Carrington Event. The Carrington Event. The Carrington Event, named after Richard Carrington, an amateur astronomer who witnessed it, was the most intense geomagnetic storm in recorded history. It occurred in September 1859 during solar cycle 10. The event began with a major coronal mass ejection, CME, from the Sun, which traveled over 90 million miles to Earth in just 17.6 hours. This solar storm caused unprecedented geomagnetic disturbances on Earth, leading to telegraph systems malfunctioning and auroral displays visible even in tropical regions. The connection between the solar flare observed by Carrington and the geomagnetic storm on Earth marked a significant discovery in understanding space weather phenomena. The Carrington event highlighted the potential hazards of solar storms on our technology-dependent society, and serves as a reminder of the importance of monitoring and predicting space weather to mitigate potential impacts. And if in the 19th century the consequences of such a solar anomaly were quite moderate, for our modern high-tech civilization it will be a real catastrophe. But we will come back to this topic a little later. Impact on Earth. Few people know, but in 2012, the most powerful solar flare since the Carrington event was recorded. Fortunately, that time the impact missed our planet. But how long will our luck last? Scientists from India have stated that they expect powerful solar flares in 2024. According to them, this could fatally affect the operation of various systems on Earth. As we mentioned, roughly every 11 years, the Sun goes through a period known as the solar maximum, during which numerous intricate dark spots appear on its surface. These spots also trigger strong bursts of energy directed towards Earth, causing magnetic storms that can damage satellites and disrupt the operation of power grids and the internet. A new study suggests that this solar maximum will occur sooner than expected, most likely in the first half of 2024. This new forecast comes from an Indian group of scientists and contrasts with NASA's latest forecast, which predicts powerful flares at the end of 2025. According to Dibyendu Nandi, the lead researcher and a physicist from the Center of Excellence in Space Sciences at IISER Kolkata, the predicted powerful solar flares could disrupt the operation of satellites, the internet, and power grids. Consequences of a solar storm. If a repeat of the Carrington event were to occur in the present day, it could have severe consequences on our modern technology-dependent society. A solar storm of similar magnitude to the Carrington event could disrupt and damage satellites, communication systems, and power grids on Earth, leading to widespread blackouts and communication failures for months or even years. The induced currents from a powerful solar storm could overload electrical transformers, causing widespread power outages that might take months to repair, affecting critical infrastructure and daily life. The economic impact of a modern-day Carrington event could be significant, with estimates suggesting damages up to $2.6 trillion in the US alone due to disrupted technology and infrastructure. Telecommunication systems will be severely affected, leading to disruptions in internet connectivity, GPS services, and other essential communication networks crucial for daily operations and emergency response. A storm like the Carrington event today will cause an internet apocalypse, leading to large-scale internet outages affecting individuals, businesses, and critical services reliant on online connectivity. And it doesn't look like anyone in our world is thinking about all the threats posed by a solar storm and preparing for them. For example, do you have a Faraday cage at least for your laptop and smartphone? Write in the comments. We have seen that the sun is not only a life-giving star, but also a source of wonder and peril. The sun is a fascinating and complex object that we are still trying to understand and appreciate. It is also a reminder of how interconnected we are with the rest of the cosmos and how much we depend on our star for our survival and well-being. That's all the facts for today. We'll get back to you in a couple days with a new dizzying investigation. Don't forget to subscribe to the channel to always be aware of the most mysterious and amazing events of civilization.